So which is bigger, absolute value of 6 or absolute value of negative 9? Right? Because what is the absolute value of negative 9? And what's the absolute value of 6? But why would someone want to tell me, thank you? Do they give you a pass? Yes, you always need a pass when you come in late. So, but what mistake would someone be making if they just told me 6? What mistake would that student be making? Why would they think that? Talia? Yeah, because they would think, oh, 6 is bigger than negative 9, so obviously the answer is 6. But they would have failed to do what first? That. The absolute value. The distance from 0, right? Exactly. Okay. So let me pass out your notes. All right, so real quick, a brief review of what we talked about yesterday. The idea about an absolute value is it's how far is something from 0. So like, for example, in the real world, if you were talking about sea level, you might talk about how high something is above sea level or about how far something is below sea level. But the distance remains the same. Like here's your sea level, right? Let's say there's a plane up here and it's 1,000 feet above, but there's some like blind fish that sees in the dark down here. That's 1,000 feet below, right? There's the same distance from sea level, right? You'd say they're both 1,000 feet away. You wouldn't say the fish is negative 1,000 feet away, right? You just say it's 1,000 feet away. Oh, no, I didn't. No, I didn't catch that, no. That didn't work, did it? You know what I mean, though, right? Those freaky fish that, okay, that live in the dark. That's what I meant. Okay. I guess a blind fish doesn't see in the dark. That's true, yeah. No, I didn't catch that at all. Okay, back. The point is, even though the fish is like negative 1,000 feet, you don't say that's how far it is away. You say it's 1,000 feet away. And that's what absolute value does. It's the distance from 0. And in the sea level example, the sea level is the 0, right? Okay. So absolute value, quick review, it's the distance of something from 0. And so it always gives you what kind of number back when you take the absolute value? Positive. It's always positive. It's never negative. It's like Unikitty. But that didn't work out. That doesn't always work out well for Unikitty. You have to let your emotions out sometimes. All right, so here's our goal today. Our goal is to be able to solve something like this, okay? What x values could I put here? And I'm not asking you to answer right now, but this is the goal. What x values, I'm again not asking you to answer right now, would go here that would make this entire equation true? And here's the thing, for absolute value equations, you're going to get 2 answers, okay? You're going to get, and I'm going to explain why. But I'm going to show you a small example. We're going to build up to this one, okay? Here's a small one. So this is an equation with an absolute value, okay? There are 2 things that we could put for x that would make this true. What's one of them? Negative 7. What's the other one? Positive 7, okay? So x can be negative 7 or x can be positive 7. Agreed? Okay. I'm using this as a model for the rest of the problems. Notice that neither of these solutions, they don't have absolute value bars anymore, right? They don't have bars anymore. And what did I take a negative and positive version of, the x or the 7? The 7. So I need you to keep those 2 things in mind as we go through all these problems. I took the x out, right? There's no more absolute value bars. And I took a positive version and negative version of the 7, whatever the constant was on the right-hand side. This is the model for everything we're about to do, so I want you to remember those things. And we're going to sort of just lead up one step at a time to this longer example that's in the I will statement. No, it's not. Bless you. So here are the steps. The first step is to isolate your absolute value expression. So you find the absolute value, you get it all alone. If you're looking at the I will statement over here, here's the absolute value, the x plus 2, but it's got what attached to it? A 3 on the outside and a negative 5 on this side. So eventually what we're going to have to do before we can deal with the absolute value, we take care of anything that's outside first. But you see this first example? There's nothing on the outside of it, right? There's nothing in multiply, there's nothing being added or subtracted. It is already all by itself. What's our math word for that? It's already isolated, right? So step 1 actually is already done. So we don't have to do step 1 on this problem. Step 1 and done. Yeah. What was step 2? What does it say? Write the equivalent equations. Here's what I mean by that. I mean this. This thing. Those two equations are the equivalent of the statement above. All right? But here's what that looks like in this example. You take what's inside, you take it out, you don't change it at all. Which piece of the equation am I going to make a positive and negative version of? What did I make a positive and negative version of here? The 7. The 7. The constant. The constant. So here, so what's inside? The stuff inside does not change. You're making two equations. You're dropping the absolute value bars. The stuff inside stays the same for your two equations. That constant number, that's the one you're making a negative version and a positive version of. Just like up there in that baby example, we did it with the 7. Here we're doing it with the 10. It's whatever the constant is on the right-hand side. Because you're saying, okay, that stuff in there, that 5x, it can either equal negative 10 and still make that true, or it can equal positive 10 and still make that true. That's what's going on. And so then once you get those two equivalent equations set up, now you solve both of them. X can be negative 2 or x can be positive 2. Now this is just a coincidence that the numbers were exactly the same. They were both 2, but one was positive and one was negative. That's not going to happen every time. Right. It just happened in this case. I mean, it happens sometimes, but not every time. So when you plug, if you were to check your work here, and I'm not going to make you check it every time, but if you put negative 2 back into the original problem, you get absolute value of negative 10 equals 10. Is that true?
Yes.
Yeah. See, it checks out, right? Same thing if you put the positive 2 there. That's why there's two different answers.
So you still do like the same stuff like distribute.
I'm so glad you asked me about distribute. Please don't ever distribute using absolute value. Write this down somewhere. Do not distribute.
So what do we do with the number on the outside?
I am going to tell you what to do with it in just a second.
She's reading her mic. I know. Wait, what?
Every time that bell rings, I feel like, oh, it's time to go. So, what changed in this next example?
There's another number.
There's a number inside. Is there anything on the outside of the absolute value? Anything in front or behind it? No. So step 1 is already done. It's already isolated. So your next step is to set up your two individual equations. So my question for you is, you know that you got to make a positive version and a negative version. Are you doing that on the stuff inside the absolute value, or are you doing that on the constant that's on that other side? The constant, right? Okay. So the stuff inside, what happens to it? Nothing, right? So you're going to bring it out of the bars. And what are you making positive and negative? The 7. So one is a negative 7 and one is a positive 7, right? No, you have to solve those. So you solve your equations. I'm going to solve mine, and then we'll come back together and check. Don't look at mine until you finished yours, okay? Because you can't unsee what you have seen, and then you'll feel like you understand when you don't understand. Your phone, Mom, please. Thank you. I always think this is so cute. Every time I see it.
Oh, my little pencil pal.
I did not mean to distract you. I did not mean to
No, I
distract you.
finished. It's okay.
Oh, okay. How are you? All right, does anybody need more time? Raise your hand if you got negative 2/3 and 4. Raise your hand. Pat yourselves on the back. Yay. All right. Next example. Center, center, focus, focus, math. Yeah. What's up here? You have to add the 5. In this problem, the absolute value piece is not isolated yet. So you have to get it isolated before you make your 2 equations, okay? So you add 5 to both sides. Yeah. And then what do you do from here?
Negative and positive.
The negative, what's getting negative and positive? The 7, right? Not the what? Right, not the stuff inside the absolute value. And what do you do with the absolute value bars? Take them, get rid of them, right? They're out of here. So you should have a 4x minus 3 equals negative 7, a 4x minus 3 equals positive 7, and then you solve both of those. So you solve yours. I'm going to solve mine. Don't look at my work because that's cheating. Don't look until you have your answers. I don't even want to know.
So do you ever walk up to someone and go,
No. Is that some meme new thing?
No, we're just stupid.
That's
Yeah.
you're just stupid. There's actually a question, so shush. Thank you. Trey. First of all, you just distracted my entire. You know how hard it is for me to keep this class on track? Second of all, this is not me. Do you even know who I am? You fail. You fail. I'm in charge. I take it personally.
Meticulous. Ask Jacob what meticulous means.
I know what meticulous is. JJ, what was your question? I don't care. What answer did you put? Oh, yes. I take 2.5 also, or 2.5 or whatever, as long as it's correct. All right. So for this last example, now what's up? It's got how many things outside the absolute value? 2. What are they? A multiplication and a subtraction. Which one do we undo first? The subtraction. Just like a regular equation, okay? I'm going to write something down. You don't need to write it because you don't have a lot of room. But I do want you to look real fast. I'm going to sort of go back in time a little bit without an absolute value. No. So I'm showing you a simpler example. You don't have to write this down. In case you look at the absolute value and you think, I don't know if I'm supposed to take care of the 3 or the -5 first. This is a simpler equation without an absolute value. In this case, what would you do first? The 5 and then the 3. It works the exact same thing with an absolute value there. Okay? You still take care of the 5 first and then the 3. So let's see what that looks like. So we're adding 5 to both sides, right? What does that give you on the right-hand side? Now, what did we write? What did I write in green up here in big capital letters, and I circled it and everything? Are we going to distribute here? You divide by 3. And then now what do? You drop it. You make a -3 and a +3. What do you do with the stuff inside? You keep it the same. All right. Do your math. Don't look at mine until you've done yours.
So